Okay, can you hear me?
Yes, teacher.
Yes, can see this screen or not?
Yeah, I can.
Okay, all right. Um, the question that you cannot answer the other day is these are examples. So this 5A, 5B we did the other day. Then number 5H, 5H very difficult. I said. Then these are the questions asked. These two questions. The this one I expand. I've shown you. Number 3 you ask, and number 5E. Okay. Okay. No one, no one here yet. Let me check.
Warna kuning cirik ni. KBW.
Okay. Right. Okay. Uh, Question number 2B. Number 2B, we have two brackets. If you want to do it as product of two functions, can. But since there's no square, nothing, you can just expand them. X multiplied by x squared, x multiplied with 1 over x. So you have these two terms, x cubed and negative 1. Then 2 over x multiplied by x squared, 2x. 2 over x multiplied
Teacher,
with negative 1 over x. This one,
teacher.
yes,
Uh, s- uh, so it's like if the power is in the bracket, means we can multiply. If the power is outside the bracket, only we cannot multiply.
yes, yes, yes. Okay, correct. So when you multiply 2 over x with negative 1 over x is 2 over x squared. So you convert all the terms to power of x so that you can differentiate. So all these terms, they are already in that form except the last term. So you move the index to the top. So you have 2x to the power of negative 2. Right. Then you differentiate one by one. 3x squared, differentiate 1 is 0, differentiate 2x is 2, differentiate this one, bring down negative 2, then the power become negative 3. So this one you just copy down, 3x squared 2, and you multiply the two numbers together first, negative 4, right? Then the x power of negative 3 you put at the bottom. Okay, right. Next one. Question number 3. Now question number 3 is like a product rule. Product rule. Okay, so how to use the product rule? So the one in pink color, I consider as one term. Then the next function, orange color. But in this form, again, you cannot differentiate because of the square root. So the square root you have to change to power of half. Okay, so now we have the product of two functions. Pink color you differentiate become 1. Then the, yes, is anything? No, right. Then the square root this term, the orange color you don't differentiate, right? Then the next one you differentiate this. So bring down the power of half. then inside the bracket you copy the same, but minus 1, the power minus 1. Then differentiate what is inside the bracket. So inside the bracket is, differentiate is 1. Then this x, okay, you keep it at the back there. So actually you're only differentiating the orange color. The other one you just leave it, right? Orange color you have to write down 1 there, just in case next time if it is not 1, then you still remember to differentiate the function. This term in front and the term at the back, they are different because the term in front is x minus 1 square root. So square root is the power half, so you put it at the top, then divide by 1. Now this term, okay, this thing is at the bottom here. The x minus 1 to the power negative half is at the bottom. The 2 is also at the bottom, right? The 2 is also at the bottom. And x times 1 is x, but this x is positive, so you put it at the top. So the second term becomes x over 2 bracket x minus 1 to the power of half. In this way, you have 4, the A, B, C, D, right? The A, B, C, D, where is it? Here, yeah, this is the A, B, C, D. Right. So you have the A, B, C, D. So we are going to do it like this, right? A, B, C, D. So coming back to this one, this is my A, this is B, this is my C, and this is my D. So we cross this over to the other side. Now when you cross it to the other side, it becomes, the 2 also cross the other side, okay? 2 and the square root of this thing multiply with the square root here. So the square root and the square root becomes 1, become 1. Okay, this one become 1. Square root multiplied by square root become power of 1. Then the 2 is still outside there. Now the other side is simpler. 1 times x is x. No number, just the x, the term alone. Then these two denominator you multiply together, multiply with 1 is the same, right? It's the same. So can you simplify? Now if you look at the top one, this thing become 1. Okay, 1, that means the 2 can multiply inside. If the power is anything other than 1, then you cannot multiply the 2 inside. So now multiply the 2 inside, become 2x. 2x plus the x behind here becomes 3x. Then the 2 multiply with the negative 1 here becomes negative 2. So you can leave the answer like this, right? You can leave the answer like this, or you change back to the square root form. Change back to the square root form, you'll get something like this. Right? And that is not all. They ask you to find the value of this thing when x is 5, because they want to find f prime 5. So f prime 5, you substitute 5 into this function here. 3 times 5 minus 2, 2 square root of 5 minus 1. 15 minus 2 is 13. 5 minus 1 is 2. 5 minus 1 is 4. Square root of 4 is 2. This square root of 4 is 2. Multiply with the 2 outside. So 2 times 2 is 4. Answer is 13 over 4. Okay. Next question here. 5e. 5e square root of x plus 1. Now this question 5e, you cannot do it any other way except using the quotient rule, except using the quotient rule. Because there's one function at the top, x to the power of half, right? So you change this to x to the power of half. At the denominator, you have x plus 1, x plus 1. So which one you should differentiate first? This one, make no mistake, you have to differentiate the numerator, that is the pink color, x to the power of half first. And this orange color, x plus 1, you have to keep. So differentiate the pink color, bring down half, half minus 1, right? Half minus 1. Then this thing you keep, x plus 1 you keep. The next step, you differentiate the orange color. Differentiate x is 1, differentiate 1 is 0. So you are left with 1. And the pink color, you just keep it at the back there. Okay, right. These terms you have to write, write again. So this x plus 1 is at the top, x to the power negative half is at the bottom. Negative half means square root of x. And the 2 here is a number, it's not a square root. So you put the number here. Over here, there's no denominator, so you just write down square root of x divided by 1. And again, we use this ABCD. Again, we use ABCD. So how to use ABCD? 2 square root x times 1. This one. So it's 2 square root x. Anything multiplied with 1 is the same thing. Then we cross over. 1 multiplied with x plus 1. 1 multiplied with x plus 1 is x plus 1. This is the 1. Then square root multiplied with square root, it become x. The square root disappear. Right? So the 2 multiplied with this thing, so the 2 is still there. So if you simplify, it will become 1, then the x and negative 2x become negative x. Now, do you know how to simplify this one? Over 2 square root x over x plus 1 square. Now this one is at the denominator, this one also at the denominator. So both will appear at the denominator, only x minus 1 is at the numerator. Now from here, from this step to this step here, can understand or not?
Teacher,
Yes.
actually is AD plus BC or AD minus BC?
Same. If it is plus, then you put the plus sign there. If minus, then you put the minus sign in between.
Oh, okay.
No, what I want to know is this step. You know this step. This step
Yes.
here, it is something like this. Let me show you over here. Let's say it is fraction, right? At the top, there's another fraction, right? This is let's say this is 1, this is 2, ayo, this is 2, then here is 3. Okay, right? So it is actually like this. It is actually like this. It's actually this one divided by 3. So the answer is answer is 1 over the 2 at the bottom there, you multiply them like this. So it is actually 1 over 6. 1 over 6. But if you see something like this, uh, fraction 1 over another fraction, uh, 3, this one is, let's say 3, something like this. What is this equal to? Can you say that this is 1 over 6? Can you
No.
say that this is 1 over 6? No.
Um,
This is actually 1.
3
This is
over 2.
actually 1, where is it? Yeah, 1 divided by 2 over 3. 1 divided by 3 over 2, sorry. 3, 2. This one is 3. So the answer is different, right? The answer is, we have
2
learned
over
since the primary school, divided by 3 over 2 is
times 2 over 3.
2 over 3. Divided by 3 over 2 is 2 over 3. So you see that whether the fraction is at the numerator in the first case, or the fraction is at the denominator in the second case, they are different. Now for this one, for this function here, this is an algebraic function. This algebraic function is at the numerator, like this case is at the numerator. So when you want to simplify, the denominator goes to the denominator. However, if the fraction is at the denominator, then you have to inverse it, terbalik, right? So you get something like this. So these are two different cases. Okay, so this one settled. You want me to explain how to do this? This one, number 5. Have you tried number 5H? 5H.
Yes,
Uh,
teacher.
it is difficult. It's difficult because
Yeah.
you can look at it in two ways. Square root of 4x plus 1 over 3x squared minus 7. You can treat it as the whole thing is a composite function because this whole thing is raised to the power of half. So when you want to differentiate, you have to differentiate the composite function first. Another way of looking at it is over here. Over here. Another way of looking at it is the square root of these two, okay, the quotient of these two. So I split the square root which is one single square root, I break it up into two square root. Square root of the numerator and square root of the denominator. Thus, this becomes quotient of two functions. Now, if you look at it this way, this is not the quotient of two functions yet, because outside there is another composite function. So if you look at it in different ways, then you should also differentiate them using different ways. Okay, right. So before I start telling you how to differentiate it, can you understand the two different ways of looking at it? One is this way, another one is this way and this way. Oh, two ways of looking at it. If you know the two ways, then I proceed to tell you how to differentiate them. Okay, Li Ying said okay, right? So if you know, then I proceed. Now the first one is by looking at it as if it is a composite function. So composite, this one bracket raised to the power half. So this is a composite function. So I have to differentiate the half, bring down half, then the half less by 1, like this. Whatever that's inside the bracket, I copy back here. This is the first step when you differentiate a composite function. So you differentiate the outside first. Then the second step is to differentiate the inside, this part. However, inside the bracket is not a simple function. Inside the bracket, it is a quotient of two functions. So when I differentiate the inside, I have to differentiate using the quotient rule. So how is the quotient rule? Quotient rule means you treat the top pink color, the bottom orange color. Differentiate the pink color, keep the orange color. Differentiate the orange color, keep the pink color. Then divide by the denominator holding square. Is this okay? Differentiate the bracket. Okay. After differentiating, you differentiate the inside. Now when you differentiate the inside, there's no more power of half. You are treating it as if it is a quotient of two polynomials. There's no longer power of half there. Okay. So until this step, is it okay or not? Until here?
Okay, teacher.
Okay. Now if you can understand this, the rest is simplification. There's no longer differentiation, just that you must know how to simplify algebraic terms. Okay, so the first one, it becomes power of negative half. The 2, I put it inside here, there's no bracket, I put it outside the bracket, cannot enter the bracket because there's a power there, power of 2. Okay, so this one and this one settle. So the top numerator, I multiply out everything and add them up. Multiply up everything and then add them up. So multiply become 12x squared minus 28 minus 24x squared minus 6x. So the x squared become minus 6x squared, minus 12x squared, sorry, minus 6x, then minus 28. Now there is a common factor here. The common factor is 2. So I take out the 2 becomes 6. Take out 2 become 3. Take out 2 becomes 14. And that 2 will cancel with the 2 at the bottom here. So once you take out and cancel, there is no more 2 here. And there is also no more 2 at the top. So this is the answer. Right? This is the answer. On this side, power of negative half, you change it to power of a positive half by reversing the top and the bottom. Inverse it, right? You inverse the function. So it becomes positive, right? Become positive. And this positive square root can cancel with the power of 2 there. This power half, this is power 2. So when you cancel this, it becomes power of 3 over 2. 3 over 2. This one, you copy back the same. Then this one, you take out the negative sign. You take out the negative sign. So finally, you have something like this. So far, okay or not?
Teacher,
Yes,
the negative sign came from the second bracket.
correct,
Negative.
correct. The first bracket already cancel with the bottom. So you see that it is no longer power of 2 here because there's a half here. So it cancel away and this is left with 3 over 2. And the negative from this one, from the second one, you take out and you put in front there. Any more question?
Teacher, the 3/2 came from where?
3/2. Okay. Now 3/2 here means the 2 means square root. The 3 means power of 3. So if it's square root, then power of 3. Okay. If it is negative, then you move to the bottom. But this one, the negative, you change to positive, you inverse it, terbalik, terbalik, the top and bottom terbalik. Yeah.
Terbalik because want to give the power half to become positive.
I show you, I show you. Let me see where to write. Not much space to write. I write here. I write here. Aiyo! This one 1, this one the 1. Okay. I write here. You see how I write here. Okay. Let's say I have a to the power of negative 3. A to the power of negative 3 is equals to, I terbalik the A, it becomes like this. One over A, but the power is now positive. Okay, so A to the power of negative 3 is actually 1 over A to the power of 3. Okay, one more example. Let's say if I have 3/2. Aiyo. Let's say if I have this one. Let's say if I have 3 over 2 to the power of a different, why like that, the power of negative 4, so how to simplify this? You have any idea how to simplify this? Same as this one here, something to the power of negative something. So something to the power of negative something. So what is this actually?
2/3 power 4.
Okay, so it's 2 over 3 to the power 4, right? Okay. So you put the fraction there. There's a 1 here. Then this one is a fraction. This one is a fraction. 2 over 3. 3 over 2, sorry, 3 over 2. 3 over 2. Then this is the bracket. This is the bracket to the power of 4. It's like this. Okay, so when you have 1 over 3 over 2 to the power of 4, then it becomes what? 1 over means it is like just now like this. This one, this one, the second, this one, this case. So when you have 1 over something, it's actually divide by that something, it's actually you terbalik the thing, right? So over here, you just terbalik it. You just terbalik it. It becomes 2 over 3. 2 over 3 to the power of 4. So in this way, when the positive power, when the negative power change to the positive power, you either you terbalik the thing, or you want to look at it whichever way you can, right? Negative, you put it at the bottom. When you put it at the bottom, it becomes like this. When you raise it back to top, you have to terbalik the thing. Now when it is like this, you can write down as 1 over a power of negative 3. How you want to look at it, it's up to you, right? So this one, number 5H, any question?
Teacher, for just now, the example you give, if I write 1 over a to the power of 3, can I? I didn't write outside the bracket.
Uh, because the top is 1, you can. But if the top is not 1, then you should write like here. Can you see the cursor? If here 1, here 1 to the power of 3 is 1. So it's 1 over a to the power of 3. So you are correct. But in this case, the second case, the top is not 1. Or maybe the top here. Here is not 1. Here is not 1. So you have to put the bracket and raise to the power 4. It means that the 2 is to the power 4, the 3 also to the power 4. Okay?
But for the a to the power of negative 3,
Can. You can write like that.
can write inside the a, right? Like
Yes,
a power.
yes. Correct. Correct. Okay. So we come back. No more already. Okay. So this is what we learned the last lesson, right? The last lesson. Okay, so in this lesson, we have finished with all the different types of differentiation. We have finished with all the different types of differentiation. So the next thing that you need to learn, the next subtopic in chapter 2 is second derivative. Now, before we do second derivative, I want to explain to you clearly what is the meaning of second derivative. Okay, right. Now, we look at one example, y equals to fx. Y equals to fx is a function of x. And if I differentiate this function of x with respect to x, we call the result the first derivative. That is the name, right? The process of creating this first derivative is to actually perform an operation. That operation is d dx. What is the meaning of d dx? It means differentiate with respect to x. Differentiate what with respect to x here? We are differentiating the y with respect to x. So can you understand the symbol that I have written there? Now this symbol They are not invented by me. They are standard symbol. All the textbook, they also write like this. So this is not something that I invented and I show you. No, no. So even if you look at more advanced textbooks, it is also written this way. D dx means differentiate with respect to x. Now, what are you going to differentiate with respect to x? You're going to differentiate y with respect to x. So a simpler way of writing d dx of y is you move the y inside, and it becomes dy dx. So the meaning of dy dx is differentiate y with respect to x. This is the first derivative. You are differentiating it the first time, so it's called the first derivative. Anything that you cannot understand, you want to ask?
No, teacher.
No. No, then I'm going to tell you this dy dx is also a function of x. I am going to differentiate this dy dx one more time. I am not starting from y. I am starting from dy dx. I differentiate the dy dx. So when I differentiate the dy dx, I am actually differentiating the y the second time. And this is called the second derivative. In words, differentiate dy dx with respect to x. Differentiate dy dx with respect to x. No need to this word again. So no need this word again. So we just say differentiate dy dx with respect to x. Now, how are you going to write differentiate dy dx with respect to x? Of course, which we know is differentiating the second time. So it is called the second derivative. That is the name. That is the name of the thing that the result. That is the name of the result after differentiating two times. Now, symbolically, how are we going to write it in symbol form? To show that we have differentiated the y two times. So I apply this process d dx on this dy dx. One more time. Differentiate dy dx with respect to x. So it means that d dx differentiate with respect to x of this function dy dx. Of this function dy dx. So when you move this dy dx into this dy dx, into this d dx here, the thing that appear twice is the d. So I call it d2y, and the dx appear two times, so I call it dx square. Is this okay? One more time. If you differentiate dy dx one more time, it is called d2y dx square. It is not called dy square dx square. No, not like that. The y appear one time, but the d two times. D is what? D is the process of differentiation. So you differentiate two times, that's why the d appear two times. The y, you don't square the function y. The y is the original y. And this dx comes with the differentiation. So the dx also twice. So the second derivative is d2y dx square. Any question? When you differentiate two times, the symbol is d2y dx square. It's not d2 dy2. The y got no 2. Y only appear once. The d dx appear two times. Okay, so it's d2y dx square. Any questions so far? Okay, no question. Now, of course, this one they are not going to ask. Let's say if I differentiate the d2y dx square one more time, how are you going to write? You are going to write d dx of this d2y dx square. So, which actually the d3y dx cube, because the d dx appear three times. So, the d3y dx cubed, and the y only appear one time, right? Okay, so there are a few things. Of course, this one they won't ask lah. This one 3 times one they won't ask. The most they ask is 2 times only. This one d2y dx squared. Okay, right. So there are a few things that you need to take note here. I have to clarify before we do any problem, before we solve any problem on this second derivative. So the first thing I want to clarify is first derivative is dy dx. That first derivative is a noun. It is referring to dy dx. Is referring to the result after you have differentiated. That thing is called dy dx. That thing is called first derivative. Now, the first principle is not first derivative. First principle is referring to the method of obtaining dy dx. So why first? Because we obtain dy dx from the very basic, right? It's not from any formula, it's from the basic. We created the delta y, delta x. So it's from the basic that we get the dy dx. Basic from the starting is called first principle. Now, second derivative is d2y dx squared. Okay, second derivative means you differentiate the second time. Now, there is no such thing as second principle. No second principle. We only have the first principle, right? Okay, so we stop here and we get a new link, right? Get a new link.